Hello friends, in this video we are going to study the shift and rotate instructions which are available in the instruction set of 8086 microprocessor. So let us start with our topic. The shift and the rotate instructions in the 8086 microprocessor, they are used to shift the data which is stored in the register or the memory location to either left or right. And the rotate instructions, they also rotate the data which is present in the register or memory location either from left to right or to right to left or through the carry flag. Okay, so these shift and rotate instructions, they basically change the data which is stored there in the register or the memory locations. So first we will start with the shift instructions. So shift instructions, they move the binary data to the left or right by shifting them within the register or memory locations. So the data is stored in the register or memory location and they are shifted either to the left side or to the right side. Okay, now these shift instructions, they can also perform multiplication of powers of 2 to the power plus n and division of the powers of 2 to the power minus n. Now there are two types of shifting. One is the logical shifting and other one is the arithmetic shifting. The difference between the two types of shifting is that the logical shifting, it is used for the unsigned numbers and arithmetic shifting is used for the signed numbers. So whenever we want to shift an unsigned number, we will use the logical shifting, and whenever a signed number has to be shifted either to left or right, then we will use arithmetic shifting. So we can say that this logical shifting, it is for unsigned numbers, and this arithmetic shifting, it is for signed numbers. Okay, so let us study the shift instructions. There are four types of shift instructions available in the 8086 microprocessor. First is SHL and SAL instructions. These instructions shift the data which is there in the register or memory location to the left side. The difference between the two is that, let's have a diagram here. So this is how we can explain the SHL and SAL instructions. Both these instructions, you can see that their operation is same. They are shifting the binary data which is stored in the target register or the memory to the left side. Means that this will be having an MSB bit and a LSB bit. LSB is the lowest significant bit and MSB is the most significant bit. So from D0 to D7 we have an 8-bit data. So or 16-bit data can be also there. So that data, the MSB bit, the most significant bit, that will be shifted to the carry flag, and the LSB, that will be, means one by one the bits will be shifted, and at the LSB we are going to insert a 0. So in both these instructions 0 is inserted at the LSB position, and the most significant MSB bit, it will be shifted in the carry flag. So it is a shift instruction. So both the instructions, they are shifting each bit to the left side and places the MSB in the carry flag, and LSB is made 0. The destination means the target, it can be a register or a memory location. Now, how many times the number will be shifted? It can be 1, 2, 3, 4. It can be many times we can shift that number. So the number of shift, it is indicated in the instruction itself. It is given by a count value. So number of shift is indicated by a count which is given in the instruction itself. So if we see the journal format, how we can write these instructions, we can use these. We have SAL, SHL, destination, comma, count. So if we want to use the shift instruction, if we want to rotate the data to the left side, we will write the instruction SAL or SHL. Then the destination means either the register or the memory location we are going to write. And the count value means the number of bits we want to shift the data, either 1, 2, 3. So how many bits we want to shift, that will be given by the count. Okay. Let's take an example here. So we have written the instruction here, move BL, comma B7H, then SAL BL, comma 1. So here we want to shift the instruction to the left side, and we are shifting the register BL, that is the base register, the lower order base register we are using. So it will be an 8-bit data here. First we have moved the data B7 into the BL. So this BL register will be having the data B7. H means it's an hexadecimal and it's an 8-bit number. Now this 8-bit number, it has to be shifted to the left side by 1 position, because here the count value is given as 1. So if we see before execution, the contents of the BL register are if we see the bits here, so it's B7, B6, B5. So these are the 8 bits of the BL register. It is having B7 here. Okay, so B7 is denoted as 1, 0, 1, 1 and 0, 1, 1, 1. It's the B7, and we have a carry flag here. So carry flag is, suppose initially it's 0. So this was the content of the BL register before the execution of this instruction SAL. Now after execution, what the instruction says, that you have to shift the BL register to the left side by one position. So all the bits will be shifted and the MSB will be stored in the carry flag and the LSB is made as 0. So now the contents of carry flag will be, this 1 will be shifted into the carry flag. Then we have B7 to B0. LSB is made as 0 and all the bits are shifted to the left side. So 0 will be now at B7, 1 will be at B6, 1 will be at B5, 0 will be at B4, 1 will be at B3, then 1 will be at B2 and 1 will be at B1. So these are the new contents of the BL register after the execution of this instruction SAL. So now we will have, this will be 6 and it will be 8421 because it's an hexadecimal notation. So we are having 8421. Here also we are having 8421. So 4 plus 2 we are having here 6, here 8 plus 4 12, 13, 14. So if we see the notation A, B, C, D, E, N, F. A is for 10, 11, 12, 13, 14, then 15. Okay. So here we are having 8 plus 4, 12, 13, 14. So 14 we have E. So this, the new contents are 6E. Okay. So this is how the instruction SAL and SHL they works. Okay. Now if you see that in this instruction the carry flag is changed, because before the execution carry flag was 0 and here MSB was 1. So now the carry flag is 1. Also, if suppose the instruction is making the contents of the register as 0, then you can see that these instructions, they are affecting all the flags, sign flag, 0 flag, parity flag, all the flags will be affected due to these instructions. So we can say that all flags are affected. So these were the two shift instructions, SHL and SAL. Next we have the instructions SHR. For SHR, if we see the diagram, it is going to shift the register to the right hand side. Okay, because R is there, earlier L was there for left, R is here for right. Okay, this is the target register or memory. So we will having the MSB and LSB. LSB will be shifted to the carry flag and MSB is made as 0. So this is the SHR instruction. All the bits of the target register or the memory, they are going to shifted to the right hand side. How many shift will be there? That will be indicated by the count that is written in the instruction itself. So both the SHL and SHR, these instructions are shifting the contents either to the left side and one is shifting to the right side, and one of the bits in the left side we are making the LSB as 0, and when we are shifting to the right side we are making the MSB as 0. Here also the target, it can be means the destination, it can be a register or a memory location. Also all the flags will be affected and the number of shifts, they will be indicated by the count. So if we see the general format of this register SHR, it will be like we are going to write SHR, then destination, comma, count. So destination will be either a register or memory location, and count will be the number of shifts. Let us take an example. Again, we are taking the BL register and it is having the data B7H. Now we are shifting the BL register to the right hand side. So before execution, if we see, so we are having B7H here. So B7 will be, so BL register, it is having the B7 content. So now each of the bits, it is going to be shifted to the right hand side. And this MSB is now going to make 0 and LSB will be shifted into the carry flag. So after execution, the contents of the BL register will be B7 will be made 0, 1 will be shifted here, 0 will be shifted here, then 1, and this B0, that is LSB, it is 1, so 1 will be shifted here. So you can see that the MSB is now made as 0 and the LSB has been shifted to the carry flag. So carry flag before execution it was 0, after execution it has become 1, and also the contents of the registers are also changed. Okay, so this was the SHR instruction where each bit is shifted to the right hand side. Here we have to shift only one time because count is given as 1. If we want 2, then we can write here 2 and 2 bits will be, means the bits will be shifted 2 times. Okay. Next instruction we have in the shift category, we have is the SAR instruction. This SAR instruction, it is used for the signed numbers. Okay, because signed numbers, they are having we know that the MSB bit, the most significant bit, it is the sign bit. This bit indicates that whether the number is positive or negative. For negative number, this sign bit is 1. For positive number, this sign bit is 0. So this identity of the number, that whether this number is a positive or negative number, it has to be stored there. So this SAR instruction, what it does, it shifts each bit of the target register or the memory location to the right hand side. LSB is shifted to the carry flag, but MSB is not made as 0. The MSB, whether it is 0 or it is 1, it will be stored again in the MSB position. Okay, it will not be shifted. It will be shifted to the next bit position, but it is also stored at the MSB position. Suppose that we are having a number again like B7 we were having. So all the bits, we were having the BL register in which we were having the content B7. Okay, so we were having B7, B6, B5, 4, 3, 1 and 0. This is the BL register. We are having B7 as the content. So B7 we will have 1 0 1 1 0 1 1 1. Okay, so we have to shift if we are using the instruction SAR, BL and 1. So all the bits will be shifted. Here we are having the carry flag. Suppose it is 0 before the execution. After execution, when we shift, here the MSB is 1. So again the MSB will be made 1 and this 1 will be shifted to the B6 position also. So here we will be having 1, 0, 1, 1, 0, 1, 1 and this LSB is shifted to the carry flag. So now the new contents will be this and carry flag is changed from 0 to 1. So this SAR instruction, it is used for the signed numbers where the sign bit or the MSB bit, it indicates that whether the number is positive or negative. So that information of the number, it is stored, it is not deleted. The old MSB is made as the new MSB. Okay, and also this MSB is shifted to the B6 position also. Okay. So these are the four shift instructions we were having: SHR, SHL, SAR and SAL. Okay, two are for the logical shifting and two are for the arithmetic shifting. Two for the left hand side shifting and two for the right hand side shifting. Okay. Now next we have the rotate instructions. So rotate instructions, they are going to rotate the information in the register or the memory location either to the left side or to the right hand side. Means through the register or memory location they are rotating the contents and also through the carry flag. Okay. So rotate instruction, it is going to rotate the information in a register or memory either from one end to another end or through the carry flag. In rotate instructions, we have four types. One is RCL, ROL, RCR and ROR. So these are the rotate instructions. L is for left and R is for right. Then we have C. C is for carry. So if you can see these instruction, it is rotate left through carry. This is rotate left. This is rotate right through carry. And this is rotate right. So these are the four rotate instructions. Let us study these instructions one by one. First, we will start with the ROL instruction. This instruction, it is going to rotate the contents of the register or memory location from the left hand side. Okay. So this ROL instruction, it is going to rotate the contents to the left hand side, all the bits to the left by some number of bit positions. MSB is placed as a new LSB and a new carry flag. Number of shift is indicated by the count and all the flags are affected. If we see the diagram for this ROL instructions, so it is going to rotate to the left hand side. This is the target register or the memory location, means the destination. The MSB bit of the target, it will be placed in the carry flag, and also it will be placed at the LSB position. So all the bits, they will be shifted to the left hand side, and MSB is placed at the LSB, they are rotated, and MSB is also placed in the carry flag. Let us take an example. So this is the format for the ROL instruction. We are going to write ROL, then the destination, whether a register or memory location, and then the count, that is the number of shifts. Now here we have used again the BL register. Contents are again B7. Now it is going to be rotated to the left and by 1 bit position. So if we see the bits, suppose before execution carry flag was 0 and BL, this register is having the contents B7. Now we have to rotate it. So 1 will be placed here at the LSB. All the bits will be shifted to the left hand side, means the number will be rotated, and also this MSB bit, it will be placed in the carry flag also. So now the new contents will be, carry flag will have 1, B7 will have 0, 1, 1, 0, 1, 1, 1, and this 1 is placed here, 1. So the new contents will be this. Okay, so this is how the instruction ROL executes. The number is rotated and the MSB is placed in the carry flag also. Next we have the instruction ROR. The ROL instruction, it was rotating the contents to the left hand side. ROR, it is going to shift the contents to the right hand side. So again we will take the same example. We are going to take the register BL having the same contents B7, but here we will rotate it to the right hand side. The LSB is now going to be placed as a new MSB and the carry flag. Taking the same example, so before execution, suppose we are having the carry flag as 0. Okay, so all the contents, they will be shifted to the left hand side. This LSB will be placed at the MSB and also in the carry flag. Okay, so now the contents will be, 1 is shifted to this side, 1 is shifted here, and carry flag has become now 1. So new contents will be 1, 1, 0, 1, 1, 0, 1, 1. So this is the rotate instruction, rotate right. LSB will be placed as the new MSB and in the carry flag. Next rotate instruction we have is the RHR and RHL. Sorry, RCL and RCR. Okay, instructions. These third instruction we have is the RCR instruction. Means rotating to the right through carry. So in this, when we are rotating to the right hand side, first the LSB was made as the new MSB and in the carry flag also. But we are rotating here through carry. So LSB will be placed in the carry flag. Carry flag will be placed at the MSB. Here move BL, B7H. RCR BL to one position. So before execution, suppose we are having the carry flag as 0. So we have to rotate through carry to the right hand side. So all the bits will be shifted to the right hand side. LSB will be placed in the carry flag and carry flag will be placed in the MSB. Okay, so now the new contents will be carry flag has become 1, 0 will be placed here in B7, then 1, 0, 1, 1, 0, 1, 1. So this is the new contents. So you can see that all these instructions, they are shifting or rotating the contents of the either the register or the memory location to the right hand side or the left hand side, or they are using the carry flag also. And all the flags are affected due to these shift and rotate instructions. Another instruction we were having is the RCL. So this is going to rotate the contents to the left hand side through carry. So if we take the same example, all the bits, they will be shifted to the left hand side. MSB will be placed in the carry flag and carry flag will be placed in the LSB position. So if we take the new contents, so new contents will be 1 will be placed here, 0, 1, 1, 0, 1, 1. This is 1, and the carry flag, it is placed at the LSB. Okay, so these are the new contents when we have executed the instruction rotate left through carry. Here also we are going to indicate in the instruction the destination and the count. So in 8086 microprocessor, we have 4 instructions for the shift operation and 4 instructions for the rotate operations. For shift, we were having SHL, SAL, SHR and SAR. For rotate, we are having RCL, RCR, ROL and ROR. Here we are shifting to the left hand side through carry and without carry. Here we are shifting to the right hand side. These are for rotating to the left hand side and to the right hand side. So in this video, we have studied about the shift and rotate instructions available in the instruction set of 8086 microprocessor. So I hope that this topic is now clear to you. Thank you.